We're recording. So if I grab this partial, and if I go to here, conjecture C28, I believe it is. C27. Do you have that? It's on. Do you guys have that? Does anyone need it? Anyone need that conjecture sheet? Let me make sure I have. Anyone else need one? So we're going to look at C27, okay? So if I come down here to C27, we already hit these other ones, okay? Let's get this one. And I'm going to put it right here, and I'm going to have my nice picture right there next to it, okay? It says, we just discovered, or I discovered for you using GeoGebra, that the vertex angle bisector conjecture. In the isosceles triangle, the bisector of the vertex angle is also the altitude, okay? Altitude. And if it goes to the midpoint, if it cuts that segment in half, what do you call that? Not the bisect, you have an angle bisector up here, but it's also if it goes to the middle of the other side, median, okay? And it's also the median of the other side, okay? So we're going to show how to prove, this part right here, prove that it's the median. Anyone see how I could prove that it's the median? What are you given? Okay. What are you given about this triangle? What type of triangle is it? Okay, so you're given isosceles triangle. Isosceles triangle, we'll call it, what letter is that? I can't see. A, B, we'll call this A, okay? A, B, C, okay? Isosceles triangle ABC. And then we could kind of say that these two sides are congruent, because that's when we constructed it, we made those two sides congruent with AB congruent to AC. What did I construct here when I constructed this segment right here? What did I call that? How did I make this? How did I draw this line? What did I use? Which tool? Angle bisector. Okay? And I have angle bisector. We'll call it DA. DA. Okay. It should really be a ray, but that's, or AD. AD. Okay. So an angle bisector cuts that angle into half, right? That's the definition of angle bisector, cuts it in half. So I have two sides congruent. I have two angles congruent. What else do I have congruent in this picture? What else is congruent to itself? BD, well, that's true, but that's what we're trying to prove, okay? We're trying to prove that this thing is actually a median. So we're trying to go from two sides and an angle bisector and prove that these two pieces are congruent, which will let me say that it's a median. Go ahead, James. I guess you could use that, okay? You could say that angle B is congruent to angle C because of the angle, but because it's an isosceles triangle, right? We already proved that the base, well, I don't think we proved that yet. that the base angles of an isosceles triangle are congruent. But how about this side in the middle? It's a shared side, right? So this, you could either say, like James said, that these triangles are congruent because of angle, side angle, right? Or side, angle, side. Yes? Therefore, this side BD is congruent to this piece CD. Therefore, this has to be a midpoint. Therefore, this has to be a median. It's kind of a lot of like steps. So I'm going to write down what it would look like if I did that. Okay? So you're going to be given AB congruent to B. So we'll do little boxes like I did before. Okay? So I'm going to make a little box here. And I'm going to say that AB is congruent to AC. And that's more or less given because it's an isosceles triangle. Something like that. Then I could also say that angle 1 is congruent to angle 2. How do I know that angle 1 is congruent to angle 2? Go ahead, Ryan. Right. So you could say that's kind of like definition of an angle bisector. Angle bisector. And then I'm going to go down a little, definition of angle bisector. And then I am going to take one more box, and I could either use Ryan's way, or since I haven't really proved that isosceles triangle, I'm just going to use this side equal to itself, okay? So I'm going to say AD congruent to AD, and like, I think Jack said it, that's a shared side, right? Shared side? Shared side. And then I could put those two things together, okay, or those three things together. That's three things, right? I'm going to put arrows on the end. We're going to make it a solid line. I'm going to put those three things together. 1, 2, 3. And now I can say that, what can I say next? Why did I do that? I have a side. I have an angle, I have a side. What does that let me prove? That those two triangles are congruent. So I could say that triangle ABD is congruent to ABD is congruent to ACD. ACD, and in this case I'm going to use side, angle, side. Okay? Now there's like a couple more kind of steps that seem like, why? You could just say now it's a median. Well, you can't really. You kind of have to say that because those two triangles are congruent, now I could say that BD is congruent to CD. Who could give me the reason for that? Go ahead, James. C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Then the next thing that you kind of have to say, I'm going to go down this way. Whoops, where'd my arrow go? Come on, arrow. There we go. Okay. The next thing that I'm going to say is therefore, okay, point D, D is a midpoint of BC. Okay. And that's more or less the definition of a midpoint. Def of a midpoint. And I'm not quite done yet. Okay. Oh, what was I trying to prove? I was trying to prove that AD is a median. Is a median to BC. Okay. And so once I know that this is a midpoint, a segment connecting a vertex to a midpoint is called a median. So now I can say that, finally, I know I'm bouncing all over the place because I'm running out of room. Okay, I'm going to do another little box here. And I'm going to say, therefore, BD, or AD, right? AD is a median, and that's definition of a median. Do you follow what I did? More or less? Okay. So you have this triangle, you prove these two triangles are congruent by side angle side. Then you can say that this piece is congruent to this piece. Then you can say, therefore, this is a midpoint. If this is a midpoint, then this piece, since it connects to that midpoint, it must also be a median to the side. So what I just did basically is I proved the second part of this conjecture. Okay? Who can just, you're going to do this in your homework, and they put boxes for you to just fill in. But how would I prove that this is also an altitude? What can I say to prove that this is also an altitude? What kind of angle does this have to be? It's got to be a 90 degree. So you start out the same way. You prove that those two triangles are congruent, right? But then you would have to say, what do these two add up to? 180. You also know that they're equal, right? Right? So these two are a linear pair, so they add to 180. You also know that these two are congruent by CPCTC. So if they're congruent and they add to 180, what do they each have to be? They each have to be 90 degrees, which means that this also has to be an altitude. You follow that deductive logic, okay? So that's kind of what you're doing in your homework. There's one more thing that you'll see in your homework that I want to talk about, okay? And that's the next conjecture. I like plain paper better. Let me see if I can draw a equilateral triangle. That's not a triangle. Let's go back. Equilateral triangle. There's a cool way to draw an equilateral triangle with GeoGebra. You want to see it? Who wants to see it? Who wants to go back to sleep? Who's so live? A cool way to draw an equilateral triangle with GeoGebra. Watch. File, new. Let's see if I can do this up. Do you want to save changes? Don't save. Okay? So if I go here and I draw, get rid of this. Get rid of that. Geometry. Okay. So if I take a circle, there's a circle, I make another circle starting on that circle and going through this point like that. And then I put a point at their intersection right here. And then I connect those three things. Segment tool, segment tool, segment tool. Boom. No. Segment tool. No. Here to here. And here to here. Here. Segment tool. There, there. And there to there. Cancel. Okay? And cancel. And then I'm going to go and I'm going to hide, 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 show hide object. I'm going to hide this object. Cancel. Cancel. Why do you keep trying to hide it? I said show hide object. Show hide object. Click on that. And click on this. There. Okay? So if I click on this thing is always going to stay an equilateral triangle. If I stretch it, it stays equilateral. Do you know why that is? Why is that thing always going to be an equilateral triangle? Because they're all, see how they're all radii of triangle, they're all radius, like this radius from here to here has got to be the same as this radius from here to here. Anyway, it's all based on radii. Anyway, properties of equilateral triangles. That's your next conjecture, C28, which says, what does it say? And the last one, is this the last one for this chapter? Is that the last one? Yeah. Okay. Equilateral triangle conjecture says that every equilateral triangle is equiangular. Conversely, every equiangular triangle is, what do you think goes in here? Equilateral. Okay? So all that means is that if it has 3 congruent sides, it's going to have 3 congruent angles. And the way, ooh, that's really bad. Oh, look at that, it worked. If 2 of these sides are congruent, what's got to be true about these 2 angles down here? These are congruent, right? If it's equilateral, what has to be true about this side and this side? What has to be true about this side and this side? They're equal as well, right? So what would have to be true about this angle and this angle up here? They're also congruent, right? So if I call this A, B, and C, right? If angle, try that again, angle. If angle A is congruent to angle C, and if angle A is congruent to angle C because it's an isosceles triangle, and angle A is also congruent to angle what? B, then what's got to be true about angle A and angle C? If A is congruent to C and A is congruent to B, what has to be true? If A is congruent to C and A is congruent to B, what has to be true about B and Z? They're congruent. So that should say that angle B is congruent to angle C, right? If Sahana is 5 feet tall, and who else is 5 feet tall? Are you 5 feet tall? Oh, who else is 5 feet tall? How tall are you? And Mr. Leader is 5 feet tall, and if Sahana is as tall as me, right, and I'm as tall as Ryan, what has to be true about Sahana and Ryan? They're the same, right? So it's kind of using that 3-way argument, right? If A is equal to B and B is equal to C, then A is equal to C. So that's kind of what you do in that. Okay, I think we could be done. I think we could be done because you guys want to work on your own. Okay, so I'll stop talking.